Am I audible?
Yes, sir.
So we'll be starting the session in another 3-4 minutes. And good evening, sir. Rajkumar, sir.
Yeah, good evening, sir. I'm audible.
Good evening, sir. Yes, sir. Yes, sir. You are audible, sir.
Yeah, thank you so much.
Okay. So we will be starting in another 3 minutes, sir.
Yeah, fine. Let them join, sir. No problem.
Okay, sir. Yeah. Very good evening to all. I request Professor Nimit Sharma, ma'am, to give the insight about today's topic. Nimit Sharma, ma'am, am I audible?
So,
Yes, ma'am.
yeah, sorry, sir. So, good evening, everyone. Welcome back to the second day of our FDP on data analysis using Jamovi and eViews. So, we have Dr. Rajkumar Chavan with us. Yesterday, we learned the techniques of correlation and regression analysis. Today, we'll be taking a step further and learn confirmatory factor analysis with Jamovi. So, this topic today is essential for validating measurement models and is widely used in academic research. I encourage all the participants to actively engage, ask questions, and make the most out of this hands on session. Thank you. Over to you, sir.
Yeah. Hello. Good evening.
Good evening, sir.
Yeah. Is the voice is clear?
Yes,
Yes,
sir.
sir.
Yes, sir.
Yeah. Perfect. Perfect. So let me start the session. Share the screen.
Oh my God, there are blue cuties, not the blue color.
Yeah. Uh, is my screen is visible?
No, sir.
Yes.
Yes, sir. Yes, sir. Now it's visible.
Okay. So once again back to the day two. So today, what we discussing the topic is confirmatory factor analysis, and quickly let me take you back, and we'll discuss what exactly we discussed in the previous session. The very important things what we discussed in the last class is the x variable and y variable. The when we talk about x variable and y variable, we discuss what type of test you need to apply when it comes to different types of x and y variable. So we discussed that if there are two categorical variable, we apply chi-square test. If there are two continuous variable, we apply correlation regression. If x is categorical and y is continuous, we apply ANOVA or t-test samples, MANOVA and ANCOVA. If x is continuous and y is categorical, we apply something called as binary logistic regression, where we define the binary logistic regression in the terms of binary number, either it is 0 or 1, right? Then we have some discussion related to variable before that, like what is categorical and numerical, nominal, ordinal, discrete and continuous. That was a discussion we had. And then we discussed what exactly is the concept of how to run the correlation. So we discussed correlation is a standardized term which has its own range, which starts from -1 to +1, the value of correlation. And then once the correlation is completed, we discuss regression. And in regression, very important thing is we discuss something called as hierarchical regression model. So in hierarchical regression model, we do something called as hierarchy. So where we take the variables like each time we keep on adding new variable and we change, there is a change in the R square value, which is nothing but explanatory value because of the change in X value. So the R square keep on changing, that is, and we decide the models. So we prepare two models, model one and model two. So we got to know that in model two, there was a R square was higher in second module, but there is a one technique which I told you yesterday, that how to decide and how to take which model specifically, that is based on something called AIC value. So what is AIC? So when we talk about AIC, it is nothing but Akai information criteria. The lower the AIC value, that particular model will be selected for our decision purpose, right? So that was the discussion in till last in the yesterday session. So today, let us continue from. Hello.
Yes, sir, you are audible, sir.
Yeah, I think somebody ask any doubts. Okay,
No, sir.
so fine. To discuss confirmatory factor analysis, first let us talk about, let me, a few minutes, I want to discuss with you something called as EFA. That is, because to know confirmatory, first let me little bit talk about something called exploratory factor analysis. Then I will come to what is confirmatory factor analysis. So EFA stands for exploratory factor analysis. Okay, it is exploratory factor analysis. So now what is this technique and why it is so important? Let's try to understand. Let's imagine in your data, okay, in your data, there are many variables are there. We call it as many variable means we call it as there are large number of variables are there. Okay. There are large number of variables are there. What are those variables? Let's imagine x1, x2, and x3. Okay, x3 and so on. Okay, it's multiple variables are there. What is our objectives? Instead of having so many x variable, we call it as independent variables. We convert this all multiple variable, or we can say the large variables, into something called as the few variables, right? So when I say few variables means we are talking about something called as we converting into a very few, which is more important for my data. So that is called few variables, right? So what we do exactly here, right? So when we talk about the variables, right, we converting this larger amount of variables into few variables. This is something which is required to do in something called as your explorative factor analysis. But how do we convert these large variables? Like we have so many x variables. How do we convert into small, or we can say very few minimum number? So there is a techniques which are available to convert large number of variables into few variables. The first technique which most of the time we use, that is something called as factor analysis. Okay, so what is factor analysis basically is one of the technique where we exactly convert the large number of variable into few variables, right? There is one more technique called as PCA model, right? So what is PCA stands for? It's something called as principal component analysis, right? So principal component analysis. This is one of the technique which most of the, if you come across any research papers, they must have applied something called as PCA model, or we can say PCA is a technique to do something called as data reductions, or we can say variable reductions in the models, right? So why we are doing this one? Because there are many variable may not be necessary for your model building. So you are converting into few variable which are very much essential and which are highly correlated with your study objectives, or which are related to your study. That means you're not taking all the independent variable, you're taking only those variable which are very essential for your model building. So this technique is something which is called as explorative factor analysis, where basically we convert the large variables into few variables. So we have factor analysis and one is PCA techniques, right? So what exactly we do here in this technique, we also do something called as, when it comes to exploratory factor analysis, we do something called, let us write down here, validation of, we talk about something called as validations of construct, right? This is what we need to understand. So whether it is a PCA, whether it's a factor analysis, what we do, we can do something called validation of construct, or we can say something called as creating measurement index, or we can do something called as scale construction. So this all comes under your something called as explorative factor analysis. And when we are conducting the large variable into few variable, then it means it is something also called as what? It's also called as a data reduction techniques, right? So there are three things which you we are doing under EFA. One is the validation of the construct, and one is either you can create a scale construction, scale developments, or we can say it is also called as what data reductions here, right? So this is the one important things which we do something in the form of what? Exploratory factor analysis, right? Now, let's talk about, there are few assumptions under this particular model when we do EFA. The very first assumption says that the variable what we are taking for exploratory factor analysis, the variables, it should be either interval, okay, or it can be ratios, right? It can be either interval or ratio variable, which are one of the input for your factor analysis, right? So it cannot be something on categorical. It should be on either interval or ratio. As we discussed in the previous session, interval or ratio, right, which is also comes under your something called as what? Continuous variable, right? So when I say continuous variable means those are something called as what? Numerical variables, right? So the first assumption is whatever the variable which you are taking for EFA, so the variable should be either interval or it should be a ratio variable, right? Next one, how to test these particular variables, right? Or we can say how to test when it comes to your factor analysis or exploratory factor analysis. There is a one test which is something called KMO test, right? So let me write the full form of this KMO test, which is called as Kaiser, Mayer and Olin test. Olkin test. This is the test we use basically to examine the strength of the relationship, or we can say the correlations when it comes to the factor analysis, right? So what is KMO test? Okay, basically this test is used to understand, or we can say to examine the strength of the partial correlation between the variables. So when we are applying this particular factor analysis or explorative factor analysis, so the very first thing we apply, we test with the help of something called as what? KMO test, right? So this is the test which will tell you whether there is a, how is the strength of the relationship? What is the basically the uh, association between the variables? When I say variable means between your dependent and independent variables. So this test is one of the tests which will give you the study whether to go for factor analysis further or not, to go for further test to apply or not. Okay. Is it clear till now?
Yes, sir.
Okay. Shall we proceed further?
Yes,
Okay.
sir.
Yes, sir.
Yeah. The next one is there are some criterias are there which is used to check the KMO values. Okay. That is Kaiser Meyer Olkin test value. So just try to see how to decide and what is the acceptable or we can say value when it comes to this particular models in case of KMO test value, how much it should be, right? Like we say, no, yesterday we had something called as R square, right? So we say the higher the R square, better the model. The same way when it comes to KMO test values, is there any something specific criteria or any kind of uh, certain values where we can go ahead with any model or not? So there is some depend on paper to paper. So if we read some literature, based on the literature, the authors has been defined, but there are some values which you have to understand. What is the acceptable region when it comes to particularly exploratory factor analysis in case of KMO test values. So KMO value, if it is greater than or equal to, if the value is somewhere like 0.90. So you say it's a wonderful, we can say it's a marvelous result, which is very much good. We can say the KMO value is very good. If suppose that value is somewhere between 0.8, or we can say less than or equal to KMO value of 0.90, but it should be again less than 0.90. So which means it is something called as meritorious. Still it is good only. Suppose for example, if the KMO value is 0.7 or less than equal to with the KMO value of 0.8, so we say it's an average value. If suppose if the KMO value is 0.6 or less than equal to with the KMO value of 0.7, then we say it is something called mediocre. If suppose KMO value is somewhere between 0.5 or less than equal to KMO value of 0.6, then there is a chances it's not good. It's a condition of terrible. If suppose the KMO value is less than 0.5, then we say it is unacceptable, right? So look at the values. So you will get to know that, okay, what is my criteria for selections? So if the value is less than 0.5, don't go for it. We can say it is purely unacceptable, right? Then again, you need to rethink your model and rethink your variables. You need to check which are the variables which are much more essential, and according to that, you can further test it, right? So this is where the small basic part of the discussion with related to your KMO test. And further, there is something called as Bartlett's test also. We call it as Bartlett's test of sphericity. So what is this Bartlett's test of sphericity? Let me write for one just to know, because this you will come across this kind of jargons when it comes to your exploratory factor analysis. We call it as Bartlett's test of sphericity, SPHERICTY. So this is what is this test all about? Bartlett's test of sphericity. It's nothing but we do something called, this is used to test the H naught. So H naught means what? What is H naught here? So H naught and H1 is something either null or we can say alternate hypothesis. So here H naught is your null. To test the null, that the correlation matrix is an identity matrix, and once we identify the correlation matrix, means your variables are unrelated and it is not ideal for further factors analysis. That's a basic assumptions and basic test we need to do when it comes to your factor analysis, right? So this is something which is the small introduction, because we have in depth to understand exploratory factor analysis. Before I thought to go for confirmatory factor analysis, I thought to tell you a few things about what is EFA and what we do in EFA models, and what are the assumptions, which are the test we should use, and what are the different criterias for each test, when we should accept, when we should not accept the models when it comes to EFA. And then it comes something called as Bartlett's test of sphericity, right? So these are the two important things which we covered in case of what your exploratory factor analysis. Now the comes something called as what confirmatory factor analysis, right? Is this clear till now?
Yes, sir.
Okay. So now let's talk about analysis. Now let's in depth we'll understand what is confirmatory factor analysis. When we talk about analysis, you remember friends, there are two types of analysis we have something called EFA and we have something called as CFA, right? So what is the concept of EFA? What is EFA here? So when we say analysis, when we do, so we have something called as EFA and CFA. So what is EFA here? Can anybody?
Exploratory factor
Yes, it's an exploratory factor analysis. So
analysis.
yeah, it's EFA stands for exploratory factor analysis, right? Factor analysis. What is CFA then? It is confirmatory factor analysis. Okay. Now, is there any difference between these two? Okay, let's try to first understand. When we talk about EFA, the major focus of EFA, okay, let me write here. The major focus of EFA is on underlying the structure. Okay, so EFA focuses on underlying, or we can say understanding the underlying structure. Okay, then when it comes to CFA, now what CFA means? Confirmatory factor analysis. When we say CFA, what is the major objective of CFA is to test the hypothesis, right? That examine the relationship, between, let me write between as BW, between observed and latent variable. Okay. All of you, let us understand, because this is very important for us to know what's the difference between both, right? What is the purpose of each one of them? Okay, so let me tell you. The focus of EFA is to make the understand what is the structure. As I told you, it's a basic model which we talk about either skill development, you can say, or it can be something related to your concept building, right? Where we discuss here, which is nothing but validation, or we can say constructions, right? But when it comes to CFA, what we do in CFA basically, there are two important things you should understand. We test the hypothesis, which examines the relationship between observed and latent variable. Now, the question here, very important thing is there is something called as observed, right? This is observed, and there is another something called as latent variable. So there are two types of variable which I'm using, two terms I'm using here. One is observed and one is latent variable. Now let's talk about what is this latent and what is this observed variable. Okay. Now let's try to understand here. Okay. The first, let me talk about what is latent variable or latent variable, right? So believe me, friends, in confirmatory factor analysis, we actually don't do like a regression analysis, like where we test the basically dependent, independent. But in a short and sweet, I can say latent variable, you just remember as of now, it's just like an independent variable. Okay, just like your independent variable. Is it clear? Now, what is the another variable we have? Something called observed variable. Okay, first let's try to understand. Hello. Sarvanan sir.
Yes, sir.
Yeah, I think there is some somebody was unmute.
No, sir. Please continue.
Yeah. Are you able to follow me, everyone? Please give me some chat box, at least some confirmation that are you able to follow me? Yeah. Thank you. Thank you so much. Yeah, perfect. So what is latent variable? It is something which is nothing but it works like an independent variable, right? So when I say independent variable, what exactly independent variable? They are like a cause. Okay? They are cause or they explain the observed responses. Observed responses. That is a work of your independent variable, right? The second type of variable is something called observed variable. Okay. Now, what is observed variable? If latent variable is independent variable, then observed variable, it works like a dependent variable. It works like a dependent variable. So one is independent, one is dependent, right? But remember, in confirmatory factor analysis, we never test what is the cause and effect. It's something different. I'm going to tell you that one. First, you understand this latent and observed variable because these are going to come in one case study. I'm going to take one case study. There it will come. Okay. So observed variable is like a dependent variable. So what is dependent variable? They are effect. Those are called effect variable, or we can say manifestation of latent construct. Okay. So this is something which is called of your observed variable, right? So now let's talk about when it comes to your particularly latent and observed variable. Let me show you one particular case. Okay. In that case, let's identify what is my latent variable and what is my observed variable. Okay. So till now, just try to understand what is explorative factor analysis. Focus on understanding the structure, underlying structure. CFA does something called as it examines the relationship between observed and latent variable. So what is latent variable we discussed, or we can say latent variable? It works like an independent variable, and observed variable is like a dependent variable because there is a cause and effect, right? In regression also we do the same way. There is a cause and there is an effect, right? So let me share with you the small case and then we'll try to understand. Okay. Let me share my screen. Okay. So please give me a confirmation. Can you see here, everyone?
Yes, sir, we can see.
Yes, sir.
Okay. Now all of you please concentrate here because it's a very important to base. That's a base for when we go to Jamovi to make it this one. What is this problem statement? So I'm reading the problem statement. All of you try to understand. Suppose a company is interested in evaluating the effectiveness of its brand equity dimension. Look at the word. So company is interested in evaluating the effectiveness of its brand equity dimension, specifically brand loyalty, brand awareness, and there is something called perceived quality, right? Assessing this dimension is essential for strategic decision making. The details of the latent construct considered by the company are given below. So it means the company has given you in the below what are the latent construct. The observed variable that will infer each latent constructs are identified, and each observed variable will be a direct measure of the latent variable. The observed variable details are as given below. Okay, so now let's come to down. The first one is A. For brand awareness, the observed variable statements are, so you know, right? What and all they have given here. So the first one is, can you tell me in the, how many dimension we have? Anybody, can you unmute and tell me how many dimensions we have here? Is it 1, 2 or 3 dimension?
3.
3. Perfect. What are the 3 dimension? Can you see here? The first dimension is what? Brand loyalty, brand awareness, and perceived quality. Can you see here? Right. So now what the company has done for brand awareness, the observed variable statement they have given. So what is BA here? So what is BA means brand awareness. So the first thing they are given here, okay. I am familiar with brand X and its product. BA2 is something called I can easily recall seeing the advertisement for brand X last month. And the third one is called when I think about this product, brand X is one of the first brand that comes to my mind. It's all about the first dimension. They have categorized into the further, we can say variables. So you have to identify and tell me what is observed and latent variable later on. First, let's read the questions. For brand loyalty, the observed variable statements are, so the first one is BL means brand loyalty. I'm likely to purchase brand X in the future. So this is talks about the loyalty of the product. BL2, brand loyalty 2. I prefer brand X over other brand. It can be Y, it can be Z, and it can be any other brand in the same category. It talks about the loyalty. Brand loyalty 3. I do recommend brand X to my friends and family. So it is something which is close to brand loyalty. And the last one is for perceived quality. The perceived quality is one of the dimension. Remember, okay? We can say dimension means I'm talking about the construct, right? So the perceived quality, the observed variable statements are PQ means perceived quality. Brand X offers high quality products. Brand X products offer good value for money compared to other brands. And perceived quality 3, brand X products consistently meet my expectation for quality, right? So now these are all which we have seen. There are three dimensions are there. Okay. So hope so you got this particular case, what the company is trying to understand. The company want to interested to know in evaluating the effectiveness of its brand. So the word very important, the word is how to evaluate the effectiveness of its brand, right? So let me come to here and let's find out. Okay. So now you tell me. So what we do in CFA, what is the objective of CFA? The objective of CFA is to test the hypothesis between the relationship between observed and latent variable. So now I have displayed one small case with you, all of you. So the first thing comes in my mind, what is my latent variables, right? Now tell me, latent variables, they act as a what? They act as what? Either dependent or independent? Can anybody tell me? Latent variable acts as a dependent or independent variable?
Independent variable.
Yeah, it acts like a independent variables, right? So let me write shortcut only IV. So what is IV here? Independent variable. So now you have to tell me from this particular case, okay, from this particular case, can you tell me which are the latent variable here? I have displayed the case in front of you. Can you please tell me which are my latent variable?
Brand loyalty, brand awareness, perceived quality.
Yeah, exactly. So the first one is something called as BA. We call it as brand awareness, right? This is the first one. And the second one is something called as brand loyalty, right? And the third one is something called as perceived quality, right? This is my all considered as what? Latent variable. So we identify here. What is the next one? What is the other one? Opposite of latent is what? We have something called as which variable?
Observe.
Observed variables, right? So let's talk about from this particular case, what are my observed variables, right? So tell me, observed variable is acts like a what? Act as which variable?
Dependent variable.
Dependent variable. So it is called as DV, right? So let's talk about, now you tell me, under observed variable, okay, so we have something called as many observed variable, right? We have BA, so brand loyalty. Okay, this is one. Okay, just for your clarification, this is 1, 2, and 3. Yeah, tell me. So can I say BL1 is the first one? Is it clear? So BA1, then what is the next one? BA2, and then we have something called BA3. This is the first, we can say, under brand awareness. What is the next one? We have BL. So under BL, what we have? BL1, BL2, and then we have something called BL3. That's called brand loyalty. And under PQ, what we have? PQ1, PQ2, and then we have PQ3, right? So tell me, all these are called as which variable? Observed variable. Okay. So which is nothing but we can say brand awareness 1, 2, 3, which depends on something called brand awareness. So it means the questionnaire is asked in a such a way that, okay, the data is collected all related to brand awareness. And how do we are collecting this data? On a rating of 1 to 5, or we can say 1 to 7 based on your ratings, right? How much you are, is it a 5 Likert scale or 7 Likert scale based on your research, what you have designed the scale, right? Based on your literature and based on your objective of the study, right? So this is something called as your observed variable in this particular case study, and which is your latent variable also. Is it clear till now? Hello, is it clear? Everyone?
Yes, sir.
Fine?
Yes, sir.
Sir.
Okay. So now let's move on to the next one. So now I'm trying to build now for, now we identify what is my latent and observed variable. So let's try to form one kind of a model over here. Okay. So how to form this model? Okay. So let's try to see. Okay. The first one. Okay. Let me put it here. This is your first one. 1, 2, and 3, right? So tell me how many construct we have? Is it 2 or 3?
3, sir.
So 3. You understand what is construct, right? I hope so. Basic is known. You understand what is construct. Now construct means which can be defined in your way, right? So we have brand awareness is a one construct. Brand loyalty is one construct. Perceived quality is one construct. Okay. Next one, what we are going to do, let me build this model. Okay. Just hold on. Just give me 1 second. Let me put the, so that you will understand. Okay. So now is the model is ready now? Okay. So each model, one more, let me click here. Mm, Okay, so now I am ready with the model. Okay, so let's first try to, are you able to follow me? Is it visible, everyone?
Yes, sir.
Yes, sir.
Okay, so let's try to first write down each one of them. The first one, tell me what is the first construct? What is the name of first construct? It is called as what?
Brand loyalty.
Brand
Awareness.
awareness or anything you can mention here. So we have the first one we called as brand awareness. That's the first particular construct, awareness. Then the second one is right here. It's brand loyalty. So this is your second construct. This is brand awareness. Okay, and the third one is we called as PQ. I will write here. I could have written BL, and this is your brand awareness. So under each brand, you have something called as your observed variable. The first one is PL1, right? Then you have something called PL2, PL3. So let me write here as PL2. PL3. Sorry, it's a brand awareness. Brand awareness 1, brand awareness 2, brand awareness 3. Then you have PL1. Then you have PL2. And you have something called PL3. Then you have perceived quality as 1, perceived quality 2, and then perceived quality 3. So this is your what is this called as? This is your latent construct. This is your latent construct. And which are the three latent construct? Brand awareness, brand quality, and brand perceived quality. This one, quality. What is this all? This is your first one is something called E1. So what is E1 here? What is E stands for here? Any idea? Anyone? It's nothing but epsilon. Okay, we called as error term. So it is E1. Okay. And it is this one is E2. you can say as E2. And the same way it is like keep on going. So this is your E1, E2, E3, E4, E5, E6, E7, E8, and E9. There are total for each particular observed value and each particular we can say construct. When we calculate, there is something called error in the word. Okay. And then what we do basically, whenever we are trying to find, okay, what is the first arrow? So this arrow you have to understand first. We can find the relationship between BA and BL. Okay. And we also can find the relationship between BL and PQ, and we can find the relationship between PQ and BL, right? So this also can be tested like this. So this is which we are trying to build the model over here. And what is this one? BA to BA1. So whatever we get the values, okay, the first one, this arrow, this particular arrow, we called as correlation values. We usually get there as about correlation values. So let me write it here. So whatever we get here, so between BA and BA1, what is the correlation? So each time we get something called as correlation values, right? Correlation values. So how to define the correlation values here? It's nothing but between your each of the construct and observed variable, what is the correlation value? That is called as this arrow. Okay. And the second one, here also the same thing applies. Okay. This here also we get something called correlation values. And the third one also, we get something called correlation value. So it means what? It's like this between BA to BA1. So if I'm building a model here, so it's like this BA, okay, to BA1, BA2, BA2, and then BA3. So each time, okay, each construct with its own observed value, what is the correlation between each? That is called as this arrow. Okay. Then BL with BL1, BL2, BL3, what is the correlation value between each construct to observed variable? Then PQ is a construct with PQ1, PQ2, PQ3. That is something called as correlation value between construct to observed variable. So whatever you see in the box, okay, this particular box where I have written this box. Okay, let me show you with arrow also. So, okay, what are these called as? These are all considered my observed variables. Okay. Observed variables. Is it clear now? So this is your observed variables, which are observed variable you have BA1, BA2, BA3. All these are called as your observed variable, right? Then BL1, BL2, BL3. And then you have PQ1, PQ2, PQ3. These are all observed variable, and BA, BL, and PQ. There are 3 dimensions. These are called latent construct. And against each construct, okay, with its own observed variable, we are trying to find the association. I told you when I say association means there is something called as what? A relationship between the observed and latent variable. So this is what I was trying to explain you when I was start my session. What is confirmatory factor analysis? We test the hypothesis and we examine the relationship between the observed variable and latent variable. So what is observed variable? BA1, BA2, BA3. These are all my observed variable, and BA, BL, PQ are my latent variable. So between each construct and each observed variable, what is the correlation? And that's nothing but your relationship we test in case of confirmatory factor analysis. Is it clear now? Is this concept is clear till here?
Yes, sir.
Hello? Is the basis clear till here? What we are exactly trying to do in confirmatory factor analysis?
Yes, sir.
Yes, sir.
Okay. So now, once we do, what is this diagram called as? This entire diagram, we have to give one name. So that diagram name is something called path diagram of measurement area. So the entire diagram what we drawn here, this is nothing but your path diagram, which talks about the entire theory here. Okay. So hope so the theory concept is clear now. So can we move on to now Jamovi? Shall we build this diagram in Jamovi now?
Yes, sir.
Okay. So all of you please open your Jamovi software now, everyone. Once you are ready, please raise your hand, and so that I'll get to know that you are ready with Jamovi software. Fine. So can you able to see my screen?
Yes, sir.
Okay. So all of you, I hope you know how to import the data set. I have shared one data set. So I'm going to take something called as brand equity data. I hope you have all of you with you, the brand equity data. Is it there?
Yes, sir. It's shared.
Yeah, please open that one. Then
Yes, sir.
okay. So let's try to do it now. Okay. Now can you see BA1, BA2, BA3? Can you tell me what is BA1? BA means what?
Brand awareness.
Brand awareness, right? And 1, 2, 3. Okay. Under brand awareness, you have 3 related questions related to brand awareness, and these are all responses. What do you say maximum? How much is the responses you got here? It's a 7, right? So tell me what, can you guess it? How much Likert scale this can be? Is it 5 or 7?
7.
Yeah, so it is collected on 7 Likert scale, right? So if you scroll right, you will get all this total 9 something called as observed variable. So what just now I was speaking with you, all of you, that so 1, 2, 3, PL1, 2, 3, PQ1, 2, 3. These are all nothing but your observed variable of this dimension called as BA. Okay, so let's go to here. Now, the first thing what you should do, can you see this symbol? This is something called as nominal, or it can be ordinal, right? Here the symbol is given as nominal or ordinal, correct? Can you see this symbol?
Yes, sir.
So
Yes, sir.
your job is to change this into all the variables into scale data. how to change it? All of you please concentrate on the Jamovi screen. Can you just, it's just like an Excel, okay? So can you select the first one? Double click on this. Can you select the first one and double click on this? Did you got like this screen?
Yes, sir.
Okay. Now tell me, don't change the variable name. Let it be BA1. But can you see measure type? It is already in which form? Can you see here? It is in which form?
Nominal.
Nominal. You have to change this nominal into continuous. Done? Are you able to do it?
Yes, sir.
After that, can you push it right side? Look at on the screen. You see there is a right arrow here. Just click here. You will get BA2. BA2 you should again convert into what? Nominal to which variable? Continuous. Go this one. BA you should 3 also continuous. Make it BL nominal. You have to make it continuous. Continuous BL2. Nominal to continuous. PQ1 is nominal. Make it continuous. This is nominal. PQ2, make it continuous. And the third one is continuous. That's all. Is it done, all of you? Can you see your scale? It's got changed now. Icon has got changed. Done. Right?
Yes, sir.
After doing this, can you see this up arrow? The biggest one, the up arrow. You have to just click here. That's all. Just click on this one. Okay. Am I clear? Now, is it
Yes, sir.
all got continuous now? So let's do it now. How to do? In analysis tab, do you have this option called factors? All of you have this
Yes.
option called
Yes,
factors?
sir.
So under factors, you have reliability, principal component analysis, exploratory factor analysis. What is the third one? Can you see here?
Confirmatory factor analysis.
Yeah. So what is our topic for the day? It is confirmatory factor analysis. So please click on this one. The moment you click, did you got like this? Now, under this, you have factor one. You can keep on adding those factors. But now we are going to change the name from factor one to dimensions, which are my construct. So first thing what you have to do, come on the right side, click on this factor one and change it here. Okay, make it as brand awareness. I want you to change it and rename as brand awareness. Are you able to do it? Done?
Yes, sir.
Okay, now what we have to do, tell me under brand awareness. Okay, first of all, you have to understand brand awareness is a construct. Okay, and under that we have something called as observed variables, different, right? So first one, BA1. Okay, look at here how I have to put inside the box. Click on BA1, press shift down, down, 3 variables related to brand awareness. Okay, select this, then just take it like this and push it inside the box. See, automatically it will come like this. Do it all of you and tell me. BA1, BA2, BA3, just select and put inside the box. Is it done?
Yes, sir.
Okay, next one. Tell me, what is the next factor we have? Can you click on add a new factor? Can you click on add a new factor? What's the next one? Brand
Loyalty.
loyalty. So now tell me, under brand loyalty is a construct. So tell me brand loyalty 1, 2, 3. So you have to select this BL 1, 2, 3. So again, same process, shift down, down, down. Okay. After that, what you have to do, just select and put inside this box. Are you able to do it? Done. Again, add new factor. Factor 3. Okay. What is my third factor name? Perceived. Perceived quality. So now you tell me pursued quality PQ1, 1, 2, 3. Just select like this and just put inside this box. Tell me, is it clear till now?
Yes, sir.
Yes, sir.
Okay. So now go on the right side. I think all we have done. Okay. Go on your right side. What is the first one you got? Factor loading. Okay. And after that, you have factor estimates, and then you have something called model fit. I will teach you each and everything. But before that, other things also you need to do here. Okay, after that, I just want you to go to, there is a left side. Can you see there is an option? Go to option. Okay, go to options. Under this missing value method and constraint is there. So let it be full information maximum likelihood method, as most of the popular method is MLA. We call it as maximum likelihood as method ML. And in constraint, you have to change this factor variance from 1 to make it as scale factor is equal to scale first indicator. Change it to scale factor is equal to scale first indicator. Did you change it? Clear? Hello?
Yes, sir.
Okay. Next, what is the next thing after that? You have estimate. Can you click estimate, all of you? So under estimate, you have result of factor covariance. You can take factor covariance or residual covariance also, but let it be as of now factor covariance, because covariance is something unstandardized and correlation is a standardized. So when we always go from covariance to correlation, right? So this is nothing but one way of to understand the correlation only. In statistics, it's already test statistic. I want you to enable one more option called standardized estimate. The moment you click standardized estimate, it will come like this. After p-value, standardized estimate. Is it done?
Yes, sir.
Again, there is one more option called as model fit, right? So under model fit, okay, is by default first value is ticked. Yes or no?
Yes, sir.
Yes,
Yes.
sir.
What is
Square.
this? This is called chi-square test. Okay. So let it be chi-square test. Fit measure is CFI, TLI, and you have to enable one option called SRMR. Okay. And you can also check RMSC. Already it is there. AIC is also there. If you want, you can select that one. Again, I want you to go down. Again, I want you to go down. Tell me, what is this diagram is called as? Can you see my Excel sheet? What is the name I gave to this diagram?
Path diagram.
Path diagram of measurement theory, right? So go to Jamovi. Do we have option called plot? Under plot, do you have this option called path diagram? Can you click on this one? Did you got like this? Yes or no?
Yes, sir.
Okay. So I think most of the options are done. So please, all of you, open your Word document. All of you, please open the Word document. Okay. And give heading here. Confirmatory factor analysis. So the first thing, we'll go one by one. Open the Word document. Just go here. Okay. Go to your Jamovi. One by one, we'll take it. Okay. Let me go to the first one. The first diagram result is confirmatory factor analysis. This factor loading. Right click, there is a table, copy. Just go here and paste it. Okay, right click, table, copy, paste it. I'll go to table design. This is your first table. Okay. Now here, few things I'll tell you how to integrate the values here, and then according to that, we'll go ahead one by one. The first thing is BA1, which is your observed variable with construct of brand awareness. The estimate, what we see, this A is called alpha, which is your fixed parameter, right? This is your fixed parameter. The first thing what you have to check, standard estimate. Okay, so let's see here. The SE, what is SE? The standard estimates for BA1 is how much? 0.749, which indicates that BA1 has a strong, okay, positive association with the which variable? Latent variable. With the latent variable, or you can say latent factors, right? Next one, BA2. What is the estimate value? Okay, so this is completed. BA2 estimate value is BA2 estimate value is how much? 0.678, right? With standard error of 0.0764. And what is the Z score of this? The Z score of this model is 8.87. So, and the p value is also less than 0.05, which indicates that there is a relationship, or we can say statistically relationship. There is a relationship between BA brand awareness and BA2, right? Which shows there is a high, or we can say good correlation between this particular value, right? And when we say the third one, the third value, which is something which is close to your 0.643, again, that is standard estimates, and the p value is also less than 0.05. We can say there is a high association is there between brand awareness as well as observed value of BA3, right? So what is BA3 estimate value is 1.180, and the standard error estimate value of this BA3 is 0.1603, which has a Z score of 7.37. So we say it is highly significant association between BA3 and brand awareness. right? Which is once again confirmed with something called as p-value, right? So we can also say to that the standard estimate is somewhere 0.643. We can say there is a positive relationship between BA3 and brand awareness. We call it as brand as awareness. Third item, which is nothing but from your questionnaire, what you have collected, and brand awareness, there is a high correlation between them with the standard estimate of 0.643, right? This is the results of in case of brand awareness. The same thing what you have to do, you have to test with the help of brand loyalty. So in case of brand loyalty, we can see there is also high association we found between first value. This is your alpha intercept value. And the second one, BL2, the estimate value is 1.301 with standard estimate of 0.79. So we can say there is a high association, or we can say positive relationship between the latent factor of brand loyalty. The third one is same thing. You have to interpret the values in case of perceived quality also, right? So you have to check the standard estimate value and you have to check the p-value. So now since here also we can see both the p-values are significantly less than 0.05, we can say we accept the alternative. So it means there is a strong relationship between perceived quality and perceived quality 2 observed variable with estimate of 4.186 and standard estimate of 0.750. That's the first interpretation you should write when it comes to your confirmatory factor analysis part, right? Is it clear now?
Yes, sir.
So what you should see when you are writing the interpretation, one sample I shown here, okay? You should see these two values. These are more essential and crucial for us to determine whether there is any association is there between observed variable and construct or not. Clear? Now let's go to Jamovi. After that, there is something called factor estimate. So let's copy this result also. Right click, table, copy, and go to down after this table. Just paste it here. This is the second table we got, right? We got as factor estimates. Now let's try to understand and interpret this result. So when it comes to factor covariance, or we can say factor estimate table, so what you should see, we have to see something called as what is the estimate values. The first you should observe this value. So let me highlight our text with red color. And along with this, we have to also check something called as p-value. That is your probability value. So now let me write one sample interpretation so that you can understand. So the covariance estimate is 0.1309, okay, between brand awareness and brand loyalty. Let me write here brand awareness and brand loyalty. Okay, so I'm writing for this two particular variable loyalty. The covariance estimate. So we cannot test between brand awareness and, so you know, right? Between brand awareness and brand awareness, the correlation will be always 1. So, but we want to check between brand awareness and brand loyalty, what is the covariance or result of correlation. So brand loyalty versus brand awareness, the estimate value is 0.1309 with the standard estimates of, with the SE standard estimate of 0.167, okay, 0.167. So what does mean? This relationship, okay, is statistically significant. Statistically significant. Why it is statistically significant? Since our p-value, okay, the p-value is how much? 0.026, right? Which is 0.026. Actually, It's a statistically significant, but we can say it indicate there is a relationship. It's a positive, but we can say the relationship is positive weak. Okay, so we can say indicate weak relationship, positive weak, or we can say correlation between the two construct. So see, remember brand awareness and brand loyalty both are constructs. So between the construct, within the construct, or we can say between the construct, what we see, there is a positive relationship, but this positive relationship is nothing but weak correlation. So the highlighting word is the weak correlation. Okay. So can you tell me for one particular variable, another one? So this is your brand awareness and perceived quality. Tell me, first of all, between brand awareness and perceived quality, what is the correlation value here? How much it is? Hmm. What is the value here? Covariance value.
0.08, sir.
Yeah, 0.0841, correct? So now you tell me this particular value between pursuit quality and brand awareness, the covariance value is this much, 0.0841. Whether it is a p value is greater than or less than 5% between brand awareness and perceived quality. What is a p value?
Less than 0.05,
It's
significant.
it's a significant. So it means what? It's a significant with positive correlation. But when we see the relationship between these two, the first one we got, which is very weak. This is also kind of a weak correlation, or we can say between this particular value. So there is a relationship is there between two construct, but it's a statistically construct between two construct. There is a relation, but it's a weak correlation. The same way you have brand loyalty, you can check this value and you can compare with this. Okay, now tell me the last one between the covariance of estimate between perceived quality and perceived quality. The covariance value is 0.0352, but which is P. The P value is 0.230. Tell me, is it more than or less than?
More.
It's more than how much? It's more than
0.05.
5%. Yeah, it's more than 0.05. So we can say it's indicate that there is a less variability within the factors as compared to other factors. So it means there is a less correlations, or we can say less associations within the construct. Remember, this is a factor covariance, right? So that's the meaning of this 0.230, right? Which is not statistically significant. So it means perceived quality within itself has less variability as compared to brand loyalty and perceived quality, right? So when the person is building automatically the brand loyalty, automatically what will happen, when he gets quality, when he pursues the quality, automatically the brand loyalty will increase, right? So when pursue quality increases, it means that when you get the product quality as you think it's very good as compared to other brand, then automatically brand awareness will increase. Is it clear now?
Yes, sir.
Let's go to the Jamovi. Let's talk about the next one is your model fit. We'll copy this one and just we'll paste it here. This is your model fit. Copy paste. So when we talk about model fit, again, one more table we have fit measure. Copy this one, paste it here. Auto fit to Windows. So two diagrams we had. So both the diagrams, both the tables we are going to copy and paste it. Okay. So now let's talk about this model fit. What exactly and how to interpret these values. The first one is something called as chi-square test value, right? What is a chi-square test value is how much? The chi-square test value is how much? 41.7, right? So chi-square value is 41.7. What is the p value of chi-square? You have to check this too. in model fit. Okay, this comes under your model fit. So when we say model fit means we are trying to determine whether this model what we constructed is it fitting according to the construct or not, right? The chi-square value we got and p value. Since the chi-square value is 0.014, tell me, is it less than or more than 5%? It is how much?
Yes, then.
Less than, right? So when the chi-square value is less than 5%, it indicates that the model does not perfectly fit the data. So why we say? Because our hypothesis testing based on this, it is something reverse. So what we say, if this value of chi-square, if it is less than 0.05, first understand that the model does not fit perfectly. However, it is some kind of a sensitive towards the sample size and some kind of what minor deviation also can be possibilities there in large sample, which can cause something called as what unfit to the models over there. Right. So the chi-square p value, when it comes to the standard value, it should be more than 5% as per the indication of index. And the second is fit measures. So what are fit measures? We have something called as CFI. What is CFI here? It's called as comparative fit index. The CFI stands for comparative fit index. Okay. So what is comparative fit index value is how much? 0.979. Okay. Remember one thing, if this value, if it is close to 1, okay, if this value is close to 1, it suggests that, okay, it's an excellent fit. Okay. Any, or we can say like this, or any value above 0.95 generally indicates that the model fits well relative to its null hypothesis. We can say null model. So any value above 0.95, it's considered as fit model as per CFI. What is next one? TLI. What is TLI stands for? It's nothing but it's called as Tucker Lewis index. So what is the TLI value? 0.967. Again, I told you this value is also close to 1, right? Which is close to 1. It shows that it's a good model fit like CFI, right? It's just like a CFI. So the value is should be, again, I told you it should be more than 0.909. Okay. Then what is next one? SRMR. What is SRMR? It's called as standardized root mean square residuals. Okay, that is called as SRMR. So again, how much is the value? 0.0387. So what does it does? What this SRMR value says? Okay, 0.0387, which is nothing but it measures the average discrepancy between the observed and predicted correlation. Value below 0.08, it indicates value below 0.808 indicates good fit. So it means the model is good. Okay, that is the we can say standard of this particular test, that is SMR test. What it says, it's talk about the what is the average discrepancy between your observed values, or we can say observed variable, and the predicted correlations. And any value which is below 0.08, since our value is 0.0387, it means this particular model is fit. Whatever we have drawn the model based on this parameter, it means the model is fit here, right? And the last one is something called RMSEA. What is RMSEA? Okay, that is called, we use in finance also this particular term. It's called root mean square error of approximation. Approximation. Okay. So we have got the value of, I think, how much we got? 0.0496. So what this measures? It measures the how much is the error in the model. So we can say it is also said it measures the model error, right? Error of approximation. Remember, there is some standard value below, okay, 0.06 indicates a good fit model. So I think if any value, see, we assume that our root mean square value should be as low, it should be good always. Remember, it should not be more. It means then there is a chances of high error in your model. So the value of RMS should not be greater than anything which goes above 0.06. It should be always less than 0.06. So our value is 0.0496. So which suggests that this model is perfectly fit, right? So remember, all these fit measurement criterias are fulfilled. So it means we can go with this particular model. So it means, so if I go and test this model in industry, so this can work. This model is acceptable, right? By taking the same construct and same latent variables, which we have designed for in our particular model. So it means this model anywhere, if you try to test, it will always have a perfectly fit model as compared to the whatever values we got over here, right? So this is what we say, this concept, which is something which is called as what theoretical model also, which is nothing but this part diagram is your visualization of your theoretical model, which shows that how much there is a strength between the construct and the observed variable. That is called as confirmatory factor analysis. Is it clear, everyone? Each and every this part is clear?
Yes.
Yes, sir.
Hello? Okay. So yeah, so I'm done. That's all. Yeah, I think 8:32. We started 7:02 and we completed 8:30. Any doubts? Understood the concept of CFA?
Participants, feel free to ask
Yes,
any
sir.
doubts.
Yeah.
Participants, any questions?
Okay. Thank you, sir. Thank you for the informative and insightful session on confirmatory factor analysis. So today you discussed right from data reduction, then framing constructs, making a model, and interpretation of the results after testing the fit of the model. Thank you all the participants for your active participation throughout the session. Your engagement truly makes these sessions productive and valuable for everyone. Please feel free to ask if any doubt. Not today, you may ask it tomorrow also. Then feedback form will be shared to you. Kindly fill your responses and I look forward for the upcoming sessions as we continue this journey together. Thank you. Have a wonderful evening.
Yeah, thank you. Thank you all. Thank you so much.